Take a close look at this. This water looks like it's flowing upward. But it's 100% real. At first glance, this seems to break the fundamental laws of physics. It feels like something out of a sci-fi movie, maybe an anti-gravity chamber or some clever CGI, but there are no special effects here, no video editing, and no hidden tricks. What you're witnessing is a fascinating water illusion, and the secret behind it is not in the water, but inside your own head. What's really happening is something much more interesting. Your brain is completely misjudging gravity and motion. This isn't just about a cool visual, it's a window into how your brain constructs reality itself. So how is this possible? How can a simple stream of water appear to defy gravity? Let us dive into the amazing science of perception and uncover why your brain can be so easily fooled. To understand this gravity illusion, we first need to talk about how we perceive movement. Our eyes aren't like video cameras that record a continuous stream of information. Instead, our visual system takes a series of rapid snapshots, like a camera taking pictures in quick succession. Our brain then stitches these still images together to create the smooth experience of motion we see every day. This process is called visual processing, and it's incredibly efficient. But it has its limits. Think about a classic flipbook. Each page is a slightly different drawing, but when you flip through them quickly, the character appears to move. The same principle is at play when you watch a movie, which is typically projected at 24 frames per second. Your brain fills in the gaps between the frames, creating a seamless illusion of movement. This is where the water illusion comes in. What you're seeing in these videos is not a continuous stream of water, but a series of individual droplets falling in a very precise pattern. The key to the illusion is a strobe light flashing at a specific frequency. Let's say the strobe light flashes every time a water droplet falls to the exact same position as the droplet before it. To your eyes, each flash of light captures a droplet in the same spot. When your brain stitches these snapshots together, what does it see? It sees a droplet that isn't moving. It appears frozen in midair. It's a real physics experiment playing with our perception. Now, what if we adjust the frequency of the strobe light just a little? If the light flashes slightly slower, each snapshot will capture a droplet a little further down its path. When your brain connects these dots, it creates the normal perception of water falling downwards. But here's where the magic happens. If we make the strobe light flash slightly faster, each flash will illuminate a droplet that is a little higher up than where the previous one was captured. So the first flash catches a droplet here. The next flash, which comes a fraction of a second sooner, catches the next droplet a little bit higher up in its fall. The third flash catches the next one even higher. When your brain processes these snapshots in sequence, it connects the dots from a lower position to a higher one. The result, the water appears to be flowing upwards, completely defying gravity. It's a stunning example of how our brain interprets sensory information. It's not seeing reality as it is, it's constructing a narrative based on the data it receives. This isn't CGI, it's a real-time brain illusion created by the interplay of light, water, and our own visual processing. This phenomenon is known as the stroboscopic effect. It's the same effect that can make the wheels of a car look like they are spinning backward or standing still when you see them on camera or under certain types of streetlights. The camera's frame rate, or the flickering of the light, acts just like the strobe light in our water experiment. It's capturing snapshots of the spinning wheel at just the right moments to create a motion illusion. So this water that defies gravity isn't breaking any laws of physics. Gravity is still pulling the droplets down just as it always does. The illusion is purely a product of how human vision works. Our brain is a powerful prediction machine. It's constantly making assumptions and taking shortcuts to help us navigate the world efficiently. Most of the time, these shortcuts work perfectly. They allow us to catch a ball, drive a car, and understand the world around us without having to consciously analyze every single piece of visual data. But illusions like this expose the moments when those assumptions lead us astray. Let's think about this on a deeper level. The brain isn't just passively receiving information, it actively builds our reality. What you see is not a direct reflection of the outside world, but your brain's best guess about what's out there. It combines sensory input from your eyes with your past experiences and expectations to create a cohesive picture. This is why optical illusions are so powerful. They are specifically designed to exploit the rules and shortcuts your brain uses, leading it to a conclusion that doesn't match physical reality. For example, consider the famous checker shadow illusion. Two squares on a checkerboard appear to be different shades of gray, but they are actually the exact same color. Your brain automatically adjusts for the perceived shadow, changing how you see the color of the square. It's making an assumption that a shadow makes things darker and applying it without you even realizing it. The upward flowing water is doing the same thing. Your brain assumes motion based on a sequence of images, even if that motion is physically impossible. This brings up a fascinating question. If our brains can be so easily tricked by a simple water illusion, what else is it getting wrong? This isn't meant to be alarming, but rather to highlight the incredible complexity of our own minds. Our perception is not a perfect mirror of reality. It's a carefully constructed simulation that is constantly being updated and corrected. These perception experiments are more than just fun tricks. They are valuable tools for neuroscientists and psychologists studying how the brain works. By understanding when and how our perception fails, we can learn more about the underlying mechanisms of normal visual processing. We can map out the rules the brain follows and understand the assumptions it makes. Every time you are fooled by an illusion, you are getting a glimpse into the inner workings of your own consciousness. It's a reminder that what we experience as objective reality is, in fact, a very personal and subjective construction. Think about how this applies to everyday life. Have you ever sworn you saw something out of the corner of your eye, only to turn and find nothing there? Or misjudged the speed of an approaching car? These are minor, everyday examples of your brain's predictive system making a small error. Our perception of time, space, and even the emotions of others are all influenced by these internal models. The water illusion is just a very clear and dramatic demonstration of this principle. It shows us that there can be a significant gap between the physical world and our mental representation of it. The water is falling, but we see it rising. The physics are constant, but our perception is flexible. And that is perhaps the most incredible part of this whole phenomenon. It's not about magic. It's about the beautifully complex and sometimes fallible nature of the human brain. So the next time you see something that seems impossible, take a moment to consider what might be happening. Is it really defying the laws of nature, or is it simply defying the expectations of your brain? This experiment with water, light, and frequency is a perfect illustration of how our powerful minds create our experience of the world. It's a real-life science lesson that's both humbling and awe-inspiring. It shows that reality is not always what it seems, and sometimes, the most amazing spectacles are the ones that reveal the hidden workings of our own perception. What's unsettling is that your brain does this constantly, not just with illusions, but with reality itself. It's always interpreting, guessing, and building your world from the ground up. If you want to see more real experiments that confuse your brain and explore the fascinating line between perception and reality, you'll find them right here. Thanks for watching, and don't forget to follow for more mind-bending science.